This is further to random sampling, okay? Because in the last lesson, we talked about how a simple random sample is much better than a non-random sample, like convenience sampling or volunteer response sampling, okay? Because randomness, every group of people that you want to survey has an equal chance of being selected, whereas in non-random samplings, that doesn't happen. But there are different types of random sampling, some that are better than others. So here, as an example, let's say we've broken up Winnipeg into these neighborhoods, 12 neighborhoods. Okay. Yes, there's more, but this is just for ease. Okay. I mean, one could argue, where's Fort Richmond? Where's Charles? Whatever. Okay. So there's 12 neighborhoods. And let's say we want to know the average house price in Winnipeg. Okay. What if I said, I don't want you to do it randomly? What if I said, and then I want you to, like, who knows how many homes there are, but let's just say I want you to select 1,000 homes without doing it randomly. How would you do it? What's that? Pick just from one area? No, if I said don't do it randomly, I want you to, how would you pick like 1,000 homes to go and check to see what their house price is? I said non-random. Okay. That's random. Sort of. My point is that you guys don't seem to want to do it non-randomly, which is good, because that would be called a judgment sample. So like a judgment sample would be something like this. Well, let's see. Maybe here, like I'm just randomly, or not, sorry, I'm not randomly picking homes. I'm just judging where I think it would look good. Okay, that's a judgment sample. That's a non-random sample. That is not great. So when we talk about a judgment sample, we're going to talk about a couple of things, whether they're biased or unbiased, and that refers to accuracy, and whether they're precise or not precise, that refers to variability. A lot of people think precision and accuracy mean the same thing. They don't. Accuracy means how well are you on target? Precision means if you shot at a target several times, would your shots be grouped together or would they be spread out? So for example, this one here, it's not accurate because we're nowhere near the bullseye, but it's precise because all our shots are grouped together. Okay. Here, kind of accurate, not so precise. It's a little spread out. Here, not accurate, not precise. And here is the best of both worlds, accurate and precise. So when we talk about accuracy, we're referring to bias. When we talk about precision, we're referring to variability. So a judgment sample is terribly biased. And in fact, in terms of precision, there is none, because it's not random. So there's actually no variability because it's biased. So the pros, really, there's none. And the variability doesn't matter. Doesn't matter if it's biased. And the cons, well, it's biased. And why is it biased? Because it's not random. It's just simply not a good way. You know, it'd be like driving around Winnipeg. Oh, I like the color of that house. Let's go survey that one. You know, oh, I haven't stopped at a house in a while. Let's go stop at this one. Like there's no accuracy there. You're not getting a representative sample. Okay. The next one we talked about, the simple random sample. So the simple random sample is what would you do? What would you do for a simple random sample? You should know. Let's say that there's I don't know, 200,000 homes in Winnipeg, and you want to pick 1,000 of them. So number them 1 to 200,000. Get off the wheel. Spin a wheel that has 200,000 numbers on it. So like go to the X and find a Ferris wheel and make your little spinning wheel on that. Okay, just get little tags that say 1 to 200,000 on the Ferris wheel. God, I love it when you interrupt me. I love it. Use a random number generator, generate 1,000, right? So who knows where there could be? I mean, we might hit, it's possible because of the randomness, we might hit more in some neighborhoods than others. Okay. If we did it again, we might hit other neighborhoods more than others. But at the same time, every group of 1,000 homes has an equal chance of being selected. Okay. Yep.
If you want to like the most accuracy.
Wait. Yeah, just wait, because I may answer your question. So, a simple random sample. What do we get with a simple random sample? It's the bias. Okay. So that's one of the pros, is that it's unbiased. It's also relatively easy to implement. You know, you just assign your numbers to the houses, get out a random number generator, got your 1,000, and then you go visit the 1,000 homes. Let's say you have to go visit them to get some information or something. Ooh. I was angry with that. Okay. What's a potential, like, okay, imagine this. You have to go to the homes to talk to an owner or owners to get some information about what you, okay? What could be sort of a pain about a simple random sample? What's that? Not. So I'm thinking about you going to see these homes.
It takes more time for, after you see them, there's bias, like.
No, I'm not talking about that. I'm talking about the actual random sample. They're going to go all over the city. Right. So it takes time, which means you may have to hire some other people to do it, which means it could cost money. Okay.
Yeah, I was.
Sorry, a second. Okay.
But Mr. Splirsky,
Yes.
sorry, another con be that like you get the best sampling?
Yes, you're right. And in terms of variability, it's actually moderate. Okay? So the cons, it may not be as precise as other randoms. And it could take a lot of time to implement. So you could be going all over the city. Okay. So instead of a simple random sample, what about, okay, maybe I can get you to answer this. So with a simple random sample, I could be potentially running all over the city. Okay, driving to different locations all over. I mean, maybe I picked one here, maybe one was picked for me here, one was picked for me up here, over here, and I'm going all over the place. So what might be a way to get around that? Doing a whole bunch in one place?
Select it from each different.
Okay, so you guys actually talked about stratified random sampling. So what you're saying is take all 12 neighborhoods and then say, okay, like let's say for argument's sake, for ease, mathematical ease, let's say we're going to survey 1,200. So we select 12 neighborhoods and then randomly select 100 within each one. Yes, that is a type of sampling, probably considered the best. Okay. That, and I'm going to jump down because you guys named it first, is what we call stratified random sampling. Stratified random sampling. Think of the phrase sum from all, which means you've separated your population into strata or into groups like neighborhoods, or maybe strata could be grades if you're surveying different grade, or if you want to survey high school. Maybe you break it up into the 4 grades and then survey some from each grade so you can get a good representative sample. That's so you're taking all the different categories and you're taking a little bit, you're going to random sample a little bit from each. So definitely unbiased. Okay? And definitely precise. And the reason why it's precise, has low variability, is how can I say this? We are getting a good representative sample all, I'm sorry, by ransom descent from each strata. Strata means group, the groups that we've split them up into. Okay, so obviously, these are the big cons, can be unbiased and precise. Or sorry, pros. Con? Well, but that's every type of random sampling. Well, there is kind of, and it's kind of related to the simple random sampling. You're randomly selecting from every group across the city, every neighborhood. Time consuming, much like the simple random sample. So it can be time consuming. Can be time consuming and costly. So it's a matter of sacrifice. I mean, if you've got the time, if you've got the money, this is probably where you want to go to get a really good, unbiased, low variable sample. Okay. Another possibility, and you're probably going to tell me everything that's wrong with it as soon as I say it, and that's okay. What if you kind of flipped it the other way? Instead of going some from all, what about all from some? What about if you said, okay, I'm going to pick 3 neighborhoods and survey everybody inside those neighborhoods? Can be biased, cannot be accurate, right? Could be high variability, big time high variability, especially if there's difference between the groups. What's that? Yes, absolutely. So that means it may not be an accurate measure and it could have a lot of variability in it. Exactly. But it is a type, though there is a pro to it, is that it's less timely, less time consuming, and less costly because you only have to go to 3 neighborhoods. You don't have to drive all over the city. I'm not saying it's the best. I'm saying it's a type. It might be good in some situations. It might be better than the other types, but it depends. Yes, actually, sometimes you can even do a combination of this, the type I'm talking about now, and stratified. That you can combine random sampling. Anyway, this is called cluster. Okay, just one second. This is called cluster random sampling. And cluster random sampling means that we are taking all from some. Because it's random sampling, it can be unbiased. Because you're random sampling. That's why. No, I never said 1. I said 3. I said 3 different clusters. And then you could randomly choose those 2 even better. Okay. So, but definitely that. Okay. So I'm saying that it can be unbiased because it's random. Okay, so you got to remember But this, I think we agree, is a better type of random sampling than this, but this is still a type of random sampling. And with randomness comes unbiased. It's leaning more towards unbiased than bias as soon as you introduce randomness into it. Okay, just remember that. So there are some pros, or easy to implement. Less costly. But yeah, I mean, the cons you guys sort of have. What? Okay, thank you. Can be very imprecise. As in high variability. And why does it have high variability? Because there could be large differences between the clusters. And that sort of goes what you were saying about the income level in certain neighborhoods compared to others. And we would be completely missing those neighborhoods, right? Like imagine if you were to randomly select 3 clusters, 3 neighborhoods, and then go to every home in those ones. Well, you could end up with 3 around the outside. It could be large. Large differences between the clusters. Sorry, I'm tired. My eyes are really. What? Okay. The last slide. And I'm not really going to go back to the map here. Is a systematic sample. Okay, a systematic sorry, it should be systematic. I should really put random in there. Systematic random sample. Because it's random, it's unbiased. Okay, so it's leaning towards unbiased. Yes. Moderate in terms of precision. Not great, not bad, but here's what you do. Is you say, okay, let's say that there's, let's go back and say there's, for ease, give me some easy numbers, 100,000 homes at one of them, or 200,000 homes, and we want to survey 1,000. So what we would do is we'd say, okay, 200,000 divided by 1,000 gives me 200. So that means if I were to select every 200th home at random. So what I would do is I would list all the homes from 1 to 200,000, okay? And then I would pick a number, random number between 1 and 200. And let's say I got 25. That means I would do the 25th home in the list, get its information. Do the 225th home in the list, get its information. The 425th, get its information. And by the time I get up to the total number of homes, I've got my 1,000 sample. Okay, so there is randomness to it. And it can be easy to implement if the population is lined up nicely. Okay?
Is that for one part of the city, or is that
One part of the thingy.
50? One street?
No. You're taking all the homes in the city. So let's say there's 200,000 homes in the city. Okay? And I want to sample 1,000. So that means there's 200 groups of 1,000 in 200,000. So I randomly select a number from 1 to 200. Let's say I get 25. So I go to the 25th home. Whatever number's on that list, they've already been listed, right? Just like in a simple random sample. Then, because there's 200 groups of those that I have to do, the 25th now goes add 200 to the 225th, and to the 425th, then to the 625th, then to the 825th. In that sense, it's systematic, but I randomly chose which one I was going to start surveying, right? So that's why it's systematic and random. So easy to implement if the population is lined up. So maybe you're surveying people and people are coming in somewhere or something. Yeah.
Judgment sampling also include like personal bias. Like if you're like, I guess it's the same thing.
It certainly could include personal bias.
Looking at a population and you do like a cluster random sample, but then you meet the people and you're like, actually, I don't want it. Is that what makes it?
Oh yeah, no, that's big time bias. Yeah, you can't do that. No, then it turns into a judgment and it really becomes non-random. Yeah. No, good point. Also unbiased. But remember, like I said, all the random ones are unbiased, but they have certain degrees. Okay. Cons. Well, if they're not lined up, it's not great to implement. Okay. If not lined up, hard to implement. And you could have more variability than other random sampling methods. More variability or imprecision than other sampling methods. So you've got to be able to identify these, and you've got to be able to explain how you would do it in certain situations. So let's just look at this example. And we're going to focus on stratified, cluster, and systematic. Okay, so the student council wants to conduct a survey about the use of the school library during the first 5 minutes of an all-school assembly in the auditorium. There are 800 students present at the assembly. Below is a map of the auditorium. Note that students are seated by grade level. The seats are numbered from 1 to 800. So from seats 1 to 200 are grade 12s. They're at the front. Okay, so it's showing you here in this, it's showing you the first couple of grade 12s. Okay, but then obviously there's more rows of grade 12 because we need to go all the way up to 200, right? How many rows of grade 12s would there would be? Well, one row fits 20, then 40, then 60, then 80, then 100, and then all over again. So 10 rows would do a grade, right? Okay. And then it goes to grade 11s. And then it goes, and then another 10 rows of 20 for the grade 11s. And then another 10 rows of 20 for the grade 10s. And then another 10 rows of 20 for the grade 9s. And you can see the last 2 rows here show the last of the grade 9s. Okay. So, your task how would you obtain a random sample using stratified? And we want 80 students. Stratified. We're going to ask them a question. What do you think about, or how do you use the school library or something?
Rows from like each section.
Let's say that again.
We took 2 from early grade 12, 2 from grade 11, 2 from grade.
Yes. Right. So what you're doing is you were saying the strata would be grades. Okay. So randomly select two rows of 20 from grade 12 and 11 and 9, and that would get you your 80 students randomly selected. Okay. And why would it be preferred to just a simple random sample? Forget.
More precisely for getting people who are grade.
Yes, right, because there could be differences between the grades, their opinions. So we want to make sure that every grade is accounted for, and we're accounting for every grade equally. So it's actually a good, like I said before, representative sample. Good representative sample using all 4 grades. What about a cluster? How could you do it so that, so you're going to do just, but then you can't do all the grade 12s because that's over your 80 people sample. Think of the auditorium, how it's laid out. It's okay if the groups, remember, the groups, the grades, they can be in the same cluster. Okay, what about if we said, okay, we're randomly going to select a column? Because wouldn't a column be made up of grade 9, 10, 11, 12? And then we're going to serve everybody, we're going to survey or ask everybody the question in that column. I know. Okay. So let's say, so how many are in each column? Well, there's 10 rows, 10 rows for each grade, right? So that means that there's what? 40 in each column, right? So 40 in each column. So that means that we would randomly select 2 columns. So we would just pick a number from, random number from 1 to 20, or sorry, pick 2 random numbers from 1 to 20, and then do the whole columns. So if we got 5, then we do 5, 25, 45, etc., all the way to the back. And let's say we got 16 over here, we do the same thing all the way to the back. That would make us our 80. Okay. So the clusters are columns of seats. Whereas the strata is more referring to the grades of the seats. Okay, there is a difference between strata and clusters. Okay, so randomly select two columns of 40. And notice that each grade is represented. So that's why it's not that bad, depending on how you select your clusters. And why might it be preferred to simple random sampling? Well, the big thing for clusters is that it's more efficient, it's easier to implement. That's sort of the big advantage of cluster random sampling, is the saving in time and potentially money. And finally, we wanted to say, because, and going back to the auditorium, it would be nice and easy because then all you have to do is go down a column. You don't have to worry about running to different rows. Okay, yeah,
I was gonna ask the end, maybe, after you have this question.
okay,
Yeah, go back to that.
okay, I will. How would we do it by a systematic random sampling? 800 divided by 80. Every 10th student. But then what you would do is you pick a random number from, random number from 1 to 10, start at that number, and then go to the next student 10 after. So you pick a random number. From 1 to 10, because 800 divided 80 is 10. And let's say we got 7. Then you would do 7, the 17, the 27, all the way up to the 797. And that would be 80. Okay. And like we talked about, it's got its advantages. So yeah, so it's a little, I mean, it's, make sure you do those practice questions because you want to wrap your head around the difference, especially between cluster and stratified. Okay? Because sometimes they can get a little confusing because like I said, strata does not mean the same thing as cluster. Yes.
I would say, what would you think works best out of those
I would do a strata.
Yeah.
I would do a strata. Unless you're talking about something in North America where it could be really costly to get some information. Right. So then you might, but like I said, I'm trying to think of an example. I remember one from before that uses cluster and random. Or strata. Because within the clusters, you could have certain strata, right? Like in the auditorium example, in the clusters, we had strata groups from grade 9, 10, 11, 12. Okay. So the cluster wasn't the grade, strata was the grade. The cluster was actually how we selected the group. And in this case, it was by column.